All right, so with solving radical equations, the biggest thing you want to do is kind of like when we were doing something we were doing a while back where you had to get I'm trying to remember now what it was. We were doing something where you had to get it by itself on one side. Maybe it was, maybe when we were solving square roots. Way back when we were working through some stuff with this one. So this one, you're still going to kind of go in that same thing. You're going to get the radical by itself on one side of the equation. And then after you do that, you're going to raise both sides to the power of the index. Okay. And almost all the problems we're going to do are going to be based on that. Now, after a little bit, we'll kind of show you some other ways that they'll tweak this a little bit, but that's really the biggest thing you're going to do. Radical on one side, everything else on the other side, and then you just kind of solve it out from there. So the basics of it's going to be pretty easy, but then it's the end of it's where we're going to have to tweak some things and make sure we got it okay. All right, Emma's not here today, so we can do numbers 1, 2, 3, 4, and everybody will be happy. Okay. Unless she watches the video, then she'll hear it. All right, so we've got the fourth root of x equals 2. Give you about the easiest one of these as you could get to start with. Okay, so in this case, the radical is already by itself on this side. So what we're going to do is, since it's the fourth root, we're going to raise both sides to the fourth power. And where we've got the fourth root and the fourth power, I'm going to put this over here. Should be over there, right? That's where we're used to putting it.
Yeah.
Yeah. I don't know what I was thinking. Okay, so if we put it there, you've got fourth root, fourth power, cancel each other out. You just get x. And over there on this side, just go ahead and do 2 to the fourth power. And make it 16. All right, and you do not have to worry about any absolute values in this case. Everything we're doing, we're solving it. The numbers you get are the numbers you get. We do not have to worry about, absolute values or pluses or minuses or anything like that for the first part, for the main majority of this one. There may be a couple along the way we might have to worry about a few little things, but we'll worry about that when we get there. And there's actually something that we'll do for that part when we look for those options. So right now, everything we're doing is just straight up just solving. Not worried about anything really. Okay, so let's do 4x plus 1. Or square root of 4x plus 1 minus 5 equals 0. Okay, so again, we're keeping the square root here, so let's get rid of that minus 5. So we'll add 5 to move it over here. Okay, and by moving the 5 over, now you got the radical by itself. And since it's the square root, we're going to square both sides. So now we've got 4x plus 1 equals 25. And now it's just a regular solving equation. Once we're there, now we can subtract 1 from both sides to get 4x equals 24. So then we get x equals 6. Okay, and as far as most of the radicals go, I mean, that's really all you're doing. Let me show you this one, because sometimes this one throws people off just a little bit, but it's actually really not bad at all compared to some of the ones that we'll see in a little bit. So let's do the third root of 4x minus 3 equals the third root of 7x plus 5. So in this case, 2 square roots. So people are like, well, how are we going to get them on one? Now, we could get it on one side together, but here's the thing. Index is the same here, right? So if this is a third root and this is a third root, if both of these are third roots and there's only 2 of them here and they equal each other, what does that mean about the insides? They got to equal each other, right? So if as long as it's just 2 radicals and they're both the same index, that's really no different than saying this is just 4x minus 3 equals 7x plus 5. So at that point, you really can just get rid of the radical itself. Because we could look at it saying that, okay, we're going to raise both sides to the third power. But if you do that, you've got the third root and third power, so they cancel each other out. So you're left with just 4x minus 3 and 7x plus 5. And again, now it's just a regular solving equation. And again, I like to get rid of the smaller amount of x's to try to make this thing positive if at all possible. So if the x is over here, we'll move the 5 over here to the left. And then lastly, go back and divide by 3, and right at the bottom of the paper. So we'll put that answer over here. So x would equal negative 8/3. Okay, so if you've got 2 radicals, because sometimes it throws people off a little bit when they get the 2 radicals, but as long as it's just 2 radicals and there's nothing else there than those 2, just set them equal to each other. And again, it's since they're both third roots, this third root has to equal this third root, which means whatever's on the inside has to be the same to get it to be that way. Okay, so here's the first one that's a little bit different. And if you can catch this one thing, then there's really only one other thing after that we've got to worry about. Okay, so for example 4, we're going to change it just a little bit. Instead of actually seeing a radical, they're going to do like we were doing yesterday, where they've got this in exponential form. Okay, now the long way is you can rewrite this one in radical form, but it actually makes it a lot longer if you do that one. So what we're going to do this one is that this is still, because if you were to think about this one, this would be the third root of x plus 1 squared. So this is basically your radical that's here. So the very first thing we want to do is just take this thing and divide it by 3. So we've got x plus 1 to the 2/3 equals 4. And y'all couldn't see that where I was scribbling, but yeah, where you've got this x plus 1 to the 2/3 power, it's the third root of x plus 1 squared. So this is your radical that's here, if you want to think about it that way. Okay, so we divide by 3. Now we've got the radical by itself. Now, you can rewrite it where it's in radical form, but here's the shortcut. If this thing is an exponential power, what you want to do is just raise both sides to the reciprocal power. So where we've got the x plus 1 to the 2/3 power equals 4, because we want this thing to go away so that there's just an x plus 1 that's here. So if we go back to our properties we were doing yesterday, well, the way to do that is we're going to take this whole thing and make it to the 3/2 power. Because the properties we were looking at yesterday is if this thing was raised to a power, you just multiply these together. And if you multiply those numbers together, the 2's cancel, the 3's cancel, and you're left with just x plus 1. Okay. Now, and on the right-hand side, you got a couple options you can do. This one, if you want to take this thing and rewrite it like we were doing yesterday, that this would be the square root of 4 to the third power, because it's just a number, so we should be able to get just a number off this thing. So, like we were doing yesterday, what's the square root of 4? Square root of 4 is 2. And then we're going to do 2 to the third power, so it should be 8. So that's really just x plus 1 equals 8. So then we get x equals 7. Okay. Now, here's where we're going to give you one little thing you can do on these. If you get just a number like this, where it's like 4 to the 2/3 power, and you've got a decent calculator, and again, the Texas Instruments are decent calculators, they can do this. You can actually, as long as this comes out to be a whole number, you can do this on the calculators. That if you do 4, you've got your power button here that's the rooftop looking button. If you click that, and then if you do 3 divided by 2 is your fraction there. There you go. And you got your answer. So if you've got now, if that comes up to be a decimal number, then that means obviously you won't be able to use that part of it. But if you will just take this thing you've got here, punch it in with this part of it, and just make sure that your fraction is inside parentheses, then you can actually let the calculator kind of speed that process up for you a little bit. Okay. So everybody all right with that? That seem like it's okay? Okay. Because sometimes people struggle with that one with the fractional exponent. But again, if you don't, the long way is to rewrite it, which I don't like that one. This one, if you can get in the habit of just seeing that it's a fraction that's here and raise it to the reciprocal power, it makes it real easy because this number should almost always come out to be a whole number. It could be a radical, but I think in most cases it's going to wind up being just a whole number to go through this thing. Okay, so here's the big one of the day. Here's where we got the big. This is where I need everybody kind of paying attention because if everybody was good there, those are kind of the basic samples that we've got. Here's where we're going to step it up a notch. Okay, so the big difference. Here's why you know what you're going to look for. They're going to ask you to solve, and not just solve, but you're going to check for extraneous solutions. All right. And if it's extraneous solutions, that means it's answers that don't make any sense if you actually go back and go through something. And I think we talked about that way back when, that if you had, somebody told you to, build a road going somewhere, and you're like, well, there's a huge lake in the middle of it. And they're like, that's all right, just build it right over the top of the lake. And you're like, you would need a bridge for that. And they're like, oh, you're fine, just build the road. We'll let cars just drive through it. Yeah. Or hey, we need to run this wire through here. Okay, just drill right through the air conditioner. That's fine. But it's the air conditioner. That's okay. Just drill right through. Sometimes you've got to check it because sometimes, yeah, you get an answer and you look at it, you go, well, that just doesn't really make a lot of sense when you go back and check it. So for these, you must check your answers because even though you get an answer, it may not be an answer that actually works when you go back and look and check and see what's happening here. All right, so let's go with this. Square root of 5x minus 1 plus 3 equals x. All right, so not really much different so far than what we had before. You got your radical here, you've got your plus 3. So your very first thing would be to subtract 3 and get the radical by itself. So we've got 5x minus 1 by itself. And now we've got x minus 3. Okay, so first step, still the same, still good. Then we're going to take both sides and square it because it's square root So the square root cancel each other out. We get 5x minus 1. All right, now here's where the extra work starts to kick in. Because what happens with x minus 3 squared? What do we have to do there? Yeah, that's x minus 3 times x minus 3, right? You're going to have to do the full method. Because we've got that x. It's not just, before it was just a number. You know, it was just a 3 that was over here. But now because of this extra x, now it's going to add that extra step to it. And now we're going to have to do the full method, and that's going to make this thing go out to be longer. So if we do that, we got x times x for x squared. X times negative 3. Negative 3 times x. And then negative 3 times negative 3 would be a positive 9. So if you do the full method, there's your 4 terms. And we can go ahead and combine the terms in the middle. Okay, and now here's where you've got to have all your different tools for solving, because if it was just, you know, x would be okay because we can move stuff around, we have it, but because of x squared, basically we need to move all these terms together here so that we've got a trinomial. So let's move this 5x over here. And then at the same time, let's move this plus 1 over here. So we've got 0 equals x squared minus 11x plus 10. Okay, so that one extra variable back up here, that extra x is going to cause us a big headache along the way, because now we've got a lot more steps we've got to do. And then once we're here, because again, the directions were still we had to solve, guess how we're going to solve this thing? We're going to solve by everybody's favorite, factoring, right? So now we're going to look for the factors of positive 10 that equal negative 11. I'm going to pull this up here so we can get a clean slate here when we're working through this one. So we need the factors of positive 10, where the sum is going to equal negative 11. Okay, so if we're doing, what's the only way we can get factors of 10 that's going to add up to 11? Yeah, it's got to be 1 and 10, right? I mean, 2 and 5 is not going to get us anywhere close to 11. And here's where you got to remember your factoring rules again. The b term is negative. The bigger number has to be negative, because these two signs have to match up. This sign always goes with the bigger number. To get the other number, we'll take a positive 10 divided by negative 10. That means this 1 has to also be negative. So that's going to be 0 equals x minus 1 and x minus 10. Okay, and then finally we get to do the actual solving, because now we're going to take each parentheses and set it equal to 0. And you get here and you're finally like, okay, well, this is not bad. This is just x equals 1, and this is x equals 10. Okay, but here's the thing. If they talk about extraneous solutions, you must, this is a must in this case, because a lot of times they don't tell you that there's a must where you have to check your answers. But this is a must. You must check your answers. So anytime it says extraneous solutions, you have to go back and check your answers back in the original equation that we've got here. So that was 5x minus 1 plus 3 equals x. Okay, so we're going to take x equals 1 and plug it back in here and see what we get. So that's the square root of 5 times 1 minus 1 plus 3 equals 1. So we're plugging in the 1 for x there, and we're plugging in the 1 for x there. So that is 5 minus 1, which is square root of 4. Square root of 4 is 2. So does 2 plus 3 equal 1? No. So that number, if we plug it in, it doesn't make any sense. So that means this solution it's a fake solution. It's fake news. You got to cancel it out because it's fake. If we put it in our current context there. All right, so now we're going to do it with 10. We're going to take 10 and plug it back in and check it and see what happens. So we're going to check it with 5 times 10 minus 1 plus 3. Does that equal 10? Okay, so that's 50 minus 1. That is the square root of 49, which is 7. And does 7 plus 3 equal 10? It does, doesn't it? So in that case, x equals 10 is actually a solution that checks out. So our only answer in this case is, there's only one solution that we're going to have in this case, and that is x equals 10. Because it actually does check. Okay. Is it hard? No. Is it tedious? Yeah. It's tedious, yeah. But it's not really over, because it's all stuff we've been doing along the way. It's not really hard. It's just tedious. It's just, there's a lot of work to it. It's like our elephant. You take it one bite at a time as you go through this thing. All right, last one of the day. Again, it is kind of long, so.
Why would it eat it? Does it actually eat it? What?
The snake was just hungry. It had been starving.
Square root of 5x plus 4 minus the square root of x equals 4. This one, what makes this one a little bit more difficult is there's 2 square roots. Now, if it wasn't for the equals 4, if this was equal 0, we could move this one over here. We could square both sides and we're good. Now, we're still going to kind of keep that same thought process that we still want to get one square root over here. We're going to move this square root over here. So we're going to add the square root of x to both sides.
Since I'm not going to be here during homeroom, can I go talk to Miss Kimbella?
Okay, so still separate out your square roots. We'll get the 5x plus 4 on the left-hand side. Basically, you take the easier square root and put it over here with the number. And we're going to do like we were doing before. They're square roots, so we're still going to square both sides. So if we square the square root, everything will cancel there. But it's this right-hand side that gets very tedious because we've got square root of x plus 4 squared. That, again, means we're going to do the full method, but we're not going to do it with just regular numbers. Now we're going to do it with radical numbers.
This is what you do.
Yeah. This is what we do. Yeah. Okay, so when we go full method on the right-hand side, you've got square root of x times square root of x. That's the square root of x squared, which means those will cancel and you're going to be left with just x. We've got 4 times the square root of x, which is 4 square root of x. We've got another 4 times square root of x. And then you have 4 times 4, which is 16. Okay, so on the right-hand side, we can do 4 square root of x plus 4 square root of x and make that 8 square root of x. And just like we did on the previous problem when it talked about checking for extraneous solutions, we're going to move both of these terms over here so that we can then do some solving from that part. But we're going to have to move this down because I'm at the end of the paper there. Okay, so let's move the 5x over here. And actually, let's do this. Oh, wait, no, let's do this, actually. Let's subtract just the x in this case. Because we've got this, now here we are, kind of back to what we were doing before. You've got this radical that's here. The only way to get rid of this radical is we're going to have to square both sides. So let's get this radical by itself. So let's move the x over here. And let's move this 16 over here. So we still want, because we've got this equation, and it's got a radical in it, we've got to get this radical by itself. Okay, so if we do that, we've got 4x minus 12 equals 8 square root of x. Okay. And you can do this one a couple of different ways. Because if you divide by 8 here, we can get the x by itself. But if you do that over here, you're going to wind up with fractions, right? And we don't like fractions. So let's make this let's make this as easy as we can. Because normally we would divide by 8 for this to cancel. We've got the square root of x and we'd be good to go. But if we do that over here, we're going to have fractions, and we don't like fractions. So let's just divide everything, because these are all multiples of 4. Let's just divide everything by 4. So that would leave us with x minus 3 equals 2 square root of x. Okay. And again, normally we would try to get the x all the way by itself here, but if we divide by 8, we're going to get fractions, and we do not like fractions. Most people are like, no, I don't like fractions. So let's just leave it at whole numbers. Okay. And then we're going to repeat like we were doing earlier. The only way to get rid of this radical is we're going to square both sides. Okay. And on the right-hand side, if it was just square root of x, it would just be x. But it's also going to be 2 squared. So if we do 2 squared, that would make that a 4x. And on the left-hand side, we are going to have to do the full method one more time. Yeah. So we've got to do the full method one more time. And now we're going to get x times x for x squared. X times negative 3 for negative 3x. We've got another negative 3x. And then plus 9. So that becomes x squared minus 6x plus 9 equals 4x. Okay. And we've got the trinomial here. We've got the one term over here. So let's move it over to the left-hand side so that it will look like a regular trinomial that's equal to 0. And now we're back to where we were in the previous problem. We've got a trinomial equal to 0. So we want the factors of positive 9, where the sum is going to equal negative 10. Okay. Again, it's got to be 1 and 9, because there's no way 3 and 3 is going to get us there. The b term here is negative, so the bigger number has to be negative. If we do a positive divide by negative, it means the 1 is also going to be a negative. Okay, so those are our two factors, the minus 1, the minus 9. Again, if you know your shortcuts, if that's the factors, the solutions are then we're going to just change those signs and make that a positive 1 and a positive 9. But again, because it said we've got to check for extraneous solutions here, you must check. You have to, because now there's occasionally, I'd say in a worst case scenario, you check this answer, it doesn't work. You check this answer, it doesn't work. So if neither answers work, you could then say that it's no solution, which is possible, because there may not actually be an answer that works for that particular problem. It's an actual real answer, but we've got to check it and see. Okay, so if we check back in the original equation, that was way back up here. We had square root of 5x plus 4 minus square root of x. So square root of 5x plus 4 minus square root of x equals 4. So we're going to check the 1 and see what happens. So that's square root of 5 plus 4 minus the square root of 1 equals 4. So that's 5 plus 4, that's square root of 9 minus square root of 1. So that's 3 minus 1 equals 4. And from where I'm from, 3 minus 1 doesn't equal 4. Yeah, maybe it does for Perry the Platypus, but not for me. So that one's out. So then we got to check 9. So that's the square root of 5 times 9 plus 4 minus the square root of 9. And does that equal 4? Okay, so that is 45 plus 4. That is square root of 49 minus square root of 9. That is 7 minus 3. And does 7 minus 3 equals 4? Yes, it does. So x equals 9 is the only solution that actually works. And again, sometimes both work. Sometimes you check it and they both work, which is fine. Sometimes one works. Sometimes neither one works, which again means you have no solution. So that's where you've always got to go back and just check it and see what's going on.